Bismillahirrahmanirrahim. Good afternoon, everyone. Today we will try to work on this question to prove the resistance equal the geometric parameter dot the resistivity. Sorry, and the proof number one will be the current density equal concentration of electron dot electron charge dot mobility drift mobility of electron dot electric charge. Let's say this cylinder is the conductor, something like copper, and the current here, the independent current source, the current direction from this side. We will depend on the current equation. Current equation equal the different, or we can say we can go directly to the derivation of the charge divided on the derivation of the time, like we're seeing here. And the unit is the coulomb divided on second. And after that, let's work separately on the derivation of the charge equal n dV, and extension of electron dot the dV is the derivation to the volume. dV equal the volume dot the charge of electron. The volume equal the area of the circuit or the circle. Sorry, the area of the circle. Here I write it A dot the dx, something like the distance or the length of this cylinder, this conductor. Let's keep going. Here dV equal, that's mean A dot dx dot electron charge. Electron charge, like we know, 1.6 dot exponential minus 19 coulomb. Now that's mean derivation of the charge equal NAdx, charge of electron. This work on dx. Dx is equal the drift velocity to the electron dot the derivation of the time. Or we can say dx divided on dt equal the drift velocity of the electron, the same. Now let's put the dx equal the drift velocity of electron dot dt instead of the dx here. That's mean the derivation of charge equal concentration of electron dot area dot here the drift velocity of electron dot dt dot electron charge. Now let's put the result, the last equation of derivation charge, on the equation number one. Current equal derivation of charge divided on derivation on t, the time, derivation time. That's mean what? Here we will delete all of them, and the last equation, it acts the current will be equal concentration of electron, area of the circle of the cylinder dot drift velocity of electron dot electron charge. Now let's work on this relation between the current and mobility, drift mobility. We will do some trick, some simple plan to do connect by using by benefit from the drift of mobility, electron mobility with the electron of the current, equation 3, like I write it here. Drift of electron equal drift velocity of electron divided on electric charge. What does mean? We use this equation, drift electron, drift the electron here to can calculate the velocity, drift velocity of electron by using this equation. What does mean? That's mean the drift velocity of electron will equal mobility, drift mobility of electron dot electric charge here, and the units is very important. The unit is very important here. Mobility of a drift equal centimeter square divided on second dot volt, because the unit of a drift velocity drift of electron equal centimeter divided on second, and the electric charge equal volt divided on centimeter. By that will be centimeter square divided on second dot volt. Now, like I said before, the drift velocity of electron equal electric charge dot drift mobility drift of electron. Here at equation number 3, current equation will be NA electric charge dot drift mobility drift of electron dot electron charge. Let's simplify. Let's make this equation be easier by use the electric field, absolute value of electric field equal different potential between 2 points A and B divided on distance. We can write D or L. Both of them has the same meaning. Now NA VAB divided on D dot drift mobility drift dot electron charge. From Ohm's law, the voltage equal current dot the resistance. What does mean? Let's use this trick to simplify this equation. We will divide the current on the resistance, and let's see what will happen. Divided on voltage, sorry, and let's see what will happen. Current divided on voltage, that's mean we will delete the voltage here. The equation will be the current divided on volt equal NA drift mobility divided on distance dot electric charge. After that, to make this side equal resistance, let's put the voltage divided on current equal the distance divided on NA drift mobility of electron dot electron charge. Like I said here. Now, to simplify this equation more, D, the distance divided on the area, is the geometric parameter. And like we know, the resistance equal 1 divided on N concentration of electron drift mobility dot Q electron charge. Let's write this letter, and will be the last equation here. The resistance equal this gamma, and his unit is meter minus 1 dot the resistivity, and his unit is ohm dot meter. We proved the proof number 1. Let's work on proof number 2 by using the current density equal the resistivity dot electric charge. Here, sorry, the conductivity, the current equal the conductivity dot electric charge. Let's say this equation number 8. And like we know, reverse relation between the conductivity and the resistivity, because that the resistivity, the conductivity will equal N as dot electron concentration dot drift mobility drift of electron. By that, we can write it here to be the current density equal NQE mobility drift of electron dot electron charge, electric charge field. And let's say what the relation between the resistivity with the temperature. At normal temperature, at mid temperatures, near from the room temperature, the relation is exponential relation between the resistivity and the temperature. And at a high temperature will be linearly like that. That means if we increase the resistivity more with more temperature, this line will be more and more. That's mean the relation between them at the high temperature, I repeat, is the linearly, and at normal temperature, the relation is exponentially between them. Let's ignore that. Here, this column explain to us by use it, we can explain the relation between the resistivity and with the temperature. By using this equation, rho, the resistivity, ohm dot meter equal rho naught 1 dot gamma t minus t0. By that, I calculated all these results with the temperature 100, 200, 250, 300, something like that. And after that, I calculated the conductivity to all of them. The relation will be something like, not exponentially, but not linearly, but maybe I forget it to take picture to. Will be like that. Here, the conductivity, and here the temperature. The relation will be like that. Will decrease from this point to be like that to some temperature will be something like constant. Here we have the example about, we will use this example to explain if the resistance result will change with the trend, will be different if we calculate this resistance, this conductivity, this resistivity by using pure silicon, and we will use doped silicon by by boron or phosphor. All these three results will change or will be the same. By use this example, all of this information will be clear to us. Let's start to solve it. Find the resistance of 1 centimeter to force 3 at pure silicon crystal. And after that, doped with phosphorus at C branch, doped with boron. And at last is the resistance and the conductivity, resistivity or the conductivity will affect with doped or not. Let's start with number 1. The conductivity equal the charge of electron between two brackets, concentration of electron dot mobility of electron plus concentration of holes dot mobility of holes. All of these two efficients are known at the equilibrium condition and room temperature. And at the pure silicon, intrinsic silicon, concentration of hole equal concentration of electron equal intrinsic carrier concentration. And intrinsic carrier concentration at silicon, like we know, at room temperature equal 1.5 dot exponential 10. Yes, let's put all of these results here and calculate. here the resistivity equal 432 exponential minus 8. The unit is ohm dot m 2 minus 1. And the resistivity equal one of the conductivity, and will be near from 23 approximately 23 exponential 4 ohm dot meter, and the resistance will be equal 23 dot exponential 4 ohm. Yes, by using this relation. The resistance has relation with the conductivity and has relation with the, yes, with the, here with the resistivity and here with the conductivity. Now let's go to the doped with phosphor. Phosphor belong to group 5. That means here this concentration equal ND and ND equal N. By using the mass law, N dot P equal intrinsic carrier concentration to force 2. That means here the minority equal 45 exponential 5 2 centimeter to force minus 3. By using the same equation to calculate the conductivity here at doped silicon with phosphorus equal dot 0.08 ohm meter to minus 1, and the resistivity equal 22.522 ohm ampere, and the resistance here are the same because at 1 centimeter to force minus 3. Now doped with boron, it's belong to group 3. That means there's concentration equal Na, and that means the majority and the minority equal 45 exponential 5. By using the same equation to calculate the conductivity, the conductivity at boron doped silicon equal 36 exponential minus 4 ohm dot meter minus 1, and the conductivity equal 277.78 ohm meter, and the resistance has the same number. Let's answer the last question. If any change in the resistance, conductivity, and resistivity when between the intrinsic silicon and doped silicon. Yes, here at pure concentration, at pure silicon, the resistivity more bigger than the resistivity at the doped, and the conductivity is smaller than the conductivity at doped silicon. Resistance is bigger than from doped silicon. What that means? The most important two things to us to make this conductor be very good by using at electric process, the resistance must be small and the resistivity must be small to can avoid lose amount of the electric. That means the conductivity, the resistivity, the conductivity and the resistance are affected with doped. And I explained when will be more and when will be less. That's it. Our lecture is finished. I'm very tired. Have a good day and thank you about your patience listening.